example 4. Now example 4, they want you to compare the power of two circuits. The first one's 12 volt 4 ohm. The second one 12 volt 2 ohm. So they want you to see which one will has higher power. Okay, the one with higher resistance or the one with lower resistance. So which one will have higher power? Let me see. They say a bulb. Okay, now I think assume that this is a bulb. 4 ohm light bulb. Okay, this is a bulb. Assume that this is a bulb. So the one with higher power will be brighter. The one with higher power will be brighter. So we can use this P equals to V squared over R to calculate the power, because we have the voltage and the resistance. Okay, and then the power for the 4 ohm resistor is 36 watt, and the power for the 2 ohm resistor will be 72 watt. 36 watt, 72 watt, which means the one with lower resistance has higher power. Lower resistance, higher power, and higher power means if it's a bulb, then it will be brighter. So the 2 ohm light bulb will be brighter. Same voltage or same potential difference. Lower resistance in the circuit, higher power. Lower resistance, higher power. So this is comparing power in the circuit. Comparing power in the circuit. The lower the resistance, the higher the power. 4 ohm, 2 ohm. Okay, now example 5, you will find that this is similar to the previous questions. The voltage, okay, the voltage is 12 volt, or potential difference 12 volt, and then the 2 resistor just now 4 ohm, 2 ohm in 2 different circuit, right? Okay, now we take out this resistor, okay, and put it here. So this 2 resistor is in the same circuit. Okay, it's in the same circuit. Still, the voltage is the same. So in these questions, they want you to compare the power of the resistor or the power of the light bulb. If the light bulb or the resistor are connected in series in a circuit, so they want you to compare so which one has a higher power, the one with lower resistance or the one with higher resistance. I want you to do the calculation now, okay? And then tell me which ones will has a higher power. So ideal battery with EMF 12 volt connected to 2 bulbs with resistance R1 and 4. What is the current in the circuit and the power dissipation in each bulb? Okay, the power dissipated in each bulb. The answer is the 4 ohm resistor 16 watt and the 2 ohm resistor 8 watt. If you want to find the power in a series circuit, you must find the current first. Okay, you must find the current first. So to find the current, we can use the formula V equals IR, okay? But every time when you want to use the formula V equal to IR, you must know which 2 points you are using for your V, yeah? Let's say we use this point and this point for our V, yeah? From this point to this point. So from this point to this point, the potential difference is 12 volt, okay? The resistance, from this point to this point, the resistance is 6 ohm, series circuit, 4 plus 2, 6 ohm. So therefore, the current I equal to V over R, 12 divided by 6 equal to 2 ampere. So you must find the current first. Now this question, they ask you to find the current, fine, because sometimes in the question, they won't ask you to find the current, straight away they ask you to find the power. So then always remember, for series circuit, you must find the current first, then only you can find the power. So we find the current, 2 ampere, then we can find the power by using P equal to I square R. So 4 ohm resistor, 16 watt, 2 ohm resistor, 8 watt. From here we can see that the power of the 4 ohm resistor is higher compared to the 2 ohm resistor. You see, this is different from this one. If the resistor are in 2 different circuits, separate, 2 different circuits, 2 separate circuits, the lower the resistance, the higher the power. But if the resistors are arranged in series like this, then the higher the resistance, the higher the power. It's the opposite. Just now, the lower the resistance, the higher the power. This one, the higher the resistance, the higher the power. So that's the difference. That's the difference. This is 2 separated, This is 2 separated circuit. This one is in 1 circuit. 2 resistors in 1 circuit. This one, higher resistance, higher power. Just now, higher resistance, lower power. Now this one, just now is a series circuit, right? Okay, so this one still the same. This is 12 volt potential difference, but the 2 resistor is arranged parallel. Okay, arranged parallel. Find the power. Find the power of these 2 resistor, and then see which one has higher power. The one with lower resistance or the one with higher resistance. So this is the answer. So the 4 ohm resistor, 36 watt, the 2 ohm resistor, 72 watt. Now you should realize that example 6 and example 4, they are almost the same. Almost the same. The calculations and the answer are also the same. So means that for parallel circuit is the same as 2 resistor in 2 separated circuit. Yeah, this and this are the same. The one with lower resistance, higher power. In series circuits, lower resistance, lower power. Parallel circuits, lower resistance, higher power. How to determine which one equation is used to solve the problems? Okay, it depends on what you have. Okay, it depends on what you have. You have R and V, then we use V squared over R. For this one, okay, we have current and resistance, then we use I squared R. Yes, all can use. You can use either one. All will get the same answer. If you can use that, okay? If you know how to use that, okay, you will get the same answer. Okay? For examples, this one, okay? You have R and V, right? Okay, let's take this one, okay? R and V, okay, then you can see, then you say, okay, I can find my current by using V equal to IR, right? I can use V equals to IR, my V 12, and then I, and then R is equal to 4, okay? Then my I equal to 12 divided by 4, which is equal to 3 ampere, okay? And then now you have your I already, right? So then you say, okay, now I want to use P equals to IV, okay, to find my power. So I equal to 3 and my V equal to 12, okay, then my power equal to 36 watt. Okay, fine, you see, you can still get the same answer. So either one, P equals IV, P equals I square R, or P equals to V square over R, okay, all will give you the same answer. Effective power. Okay, example 7, effective power means the sum of the power in a circuit, effective power. Okay, so let's continue with this one. Example 7, effective power. Okay, two identical bulb of resistance 3 ohm is connected to an EMF of 12 volt. Find the effective power of the circuit if the bulb is connected in series and if the bulb is connected in parallel. So you have two bulbs. Yeah, you have two bulbs. So one connected in series, another one connected parallel. So they want you to find the total power. Let's start with A. Yeah? A. Now, if the bulb is connected in series, each one 3 ohm, 3 ohm, the EMF equal to 12 volt. So the effective resistance R will be equals to 6 ohm, 6 ohm, and the potential difference equal to 12 volt because we assume that there is no internal resistance. Therefore, the power P equal to V square over R. Okay, V square over R, which is equal to 12 square divided by 6. Okay, 12 square divided by 6. So use your calculator. 24 watt. 24 watt. So that is the effective power of the circuit. You can also find the power separately. Okay, you can find the power separately. For example, okay, you can use V equal to IR. V equal to IR to find the current. So V is equal to 12 volt. And the currents, we don't know. The resistance 6 ohm. Okay, so therefore the current is equal to 2 ampere. 2 ampere. After you get the current equal to 2 ampere, then you can find the power of each bulb. P equals to I square R. Okay, so the I is 2 square and the R is 3 ohm. So this is equal to 12 watt. 12 watt. So each bulb 12 watt. 12 watt, 12 watt. So the effective power P prime is equals to 12 watt plus 12 watt equal to 24 watt. So you can also use these methods to find. Means you find the power separately. So you find the power of this one, you find the power of the first bulb and the power of the second bulb. Now since they are the identical bulb, so their power is the same. So the power of this one plus the power of this one, then you get the effective power, 24 watt. Okay, same as this one. So you can solve it separately. There's another way to find the answer, 24 watt. Then how about B? How about B? Yeah. So B, the bulb are connected parallel. Connected parallels, 3 ohm, 12 watt. You can find the power separately. Yeah? So V equal to 12 volt and the R equal to 3 ohm, right? So we can find the power P equals to V square over R. So 12 square divided by 3. 12 square divided by 3, 48. Okay, 48 watt. 48 watt. So one bulb 48 watt. This one also 48 watt because they are identical bulb. So therefore the effective power P prime is equal to 48 watt plus 48 watt, 96 watt. So you see either series circuit or a parallel circuit. Okay. So if you know the power of individual resistor or individual bulbs, then you can find the effective power by adding up the power of each bulb. Like for example, this one, 12 watt. So 12 plus 12, 24 watt. This is for series circuit. For parallel circuit, you can also do the same. 48, then you add 48 plus 48. Then you get 96 watt. Whether it's a series or a parallel circuit, you can do the same thing, which you can sum up the power of individual resistor. Okay, this one plus this one, okay, or this one plus this one. So you will still get the effective power. Now, for this one, if you don't like this method, okay, you don't like these methods, fine, you can use another one. Let's say you say, okay, I want to find the effective resistance. Okay, the effective resistance R equal to 3 ohm divided by 2. Okay, if you still remember, if they are parallel and the resistance is the same, then we can straight away divide by the resistance by the number of resistor. So 1.5 ohm, this is effective resistance. Then we can find the power directly. So power equal to V squared over R. V is 12. Okay, R is 1.5. Straight away you get 96 watt. Yeah, the same. Okay. So you can find the power directly, okay, or you can find the power of each resistor and then sum up the power. For parallel circuit, you can do this, and for series circuit also you can do this. That is effective power. So now from here we can see that connected the bulbs in parallel, we have higher power, 96 compared to 24. The sum of, or the effective power, or the sum of the power is much higher in parallel circuit compared to a series circuit. Example 8, this is for us to calculate how much time is needed to heat water. Okay, how much time is you needed to heat water from one temperature to another temperature. 800 watt heater is used to heat 250 centimeter cubes of water from 30 to 100 degrees Celsius. What is the minimum time in which this can be done? Now, from the equations or formulas of power, P equals to E over T, then we know that the energy is equals to PT. Okay, E equal to PT. And in Form 4, Chapter 4, we have learned that heat energy can be calculated by using this formula, E equal to MC theta. E equal to MC theta. Now, this E is electrical energy, electrical energy supplied by the heater, and this is the heat energy absorbed by the water. And if we assume that all the energy provided by the heater, supplied by the heater, is absorbed by the water, then we can say this E is equal to this E. All the electrical energy supply is converted to heat and absorbed by the water. So this E equal to this E. Then we can substitute this E into this E. Then the formula become PT equal to MC theta. Electrical energy supply equal to heat energy absorbed. PT equal to MC theta. And this formula can be used to find problems involving temperature change. When you see a certain temperature change to another temperature, then you can use this formula. So in these questions, the power is equal to 800 watt. The power 800 watt, and then the volume of the water, V equal to 250 cm cube. And the density is given in meter cube, so we better change this to meter cube. 250 cm cube is equal to how many meter cube? Can any of you tell me? 250 centimeter cube is equal to how many meter cube? So from cm cube to meter cube, we divide by 1 million. Divided by 1 million, because 1 meter cube is equal to 1 million cm cube. So we divide by 1 million. So after you divide by 1 million, then what do you get? Yes, 250 times 10 to the power of negative 6. 250 times 10 to the power of negative 6, and this is equals to 2.5 times 10 to the power of negative 4. Okay, so this is the volume. After that, we learned that the change of the temperature, theta, is equals to 100 minus 30, which is equal to 70 degrees Celsius. And they want us to find the time taken. Specific heat capacity is equals to 4,200 joule per degree Celsius per kg, yeah? Per kg, okay? And we are asked to find the time. Now, we don't have m yet, right? So we can find m by using the formulas of density, yeah? Density. Density is equals to mass over volume. So therefore, mass equal to density times volume, and the density is 1000. So 1000 times the volume, 2.5 times 10 to the power of -4, okay? So it's equal to how many kg? 0.25 kg, okay, 0.25 kg. Okay, now, so we have all the information that we want. So then we use this formula, PT equals to MC theta, okay? P is the power, 800, T we don't know, M 0.25, C 4200, and theta 70. Okay, so how much time taken? So about 92 seconds, right? 92 seconds now, because this is two significant figure, 2 or 3 significant figure, okay? 92 seconds or 91.9, okay, or 91.9 seconds, okay? So these two are acceptable. So the time taken is about 92 seconds. Here you need to know how to find mass from density, yeah? Density equal to mass over volume, so mass equal to density times volume. And you need to know how to convert cm cube to meter cube, because the density are given in meter cube. After you know all this, okay, then you get all the information that you want, then you can find your answer by using this formula, PT equal to MC theta.